A very good morning to all of you. So, as mentioned earlier, today we will be solving the question bank provided by the Nagaland Board of School Education for class 12. We'll start off with the 4 mark questions. Definitely, it's going to take a very long time, so I hope and I believe and I'm sure that all of you have come prepared with your books, your water, your refreshment, because we are going to be here for at least, I believe, 2 hours. So, I hope you have come mentally prepared. There are, of course, many questions which actually are of the revised syllabus. So we are going to be skipping those questions. So anyway, without wasting much time, since it's definitely going to take a long time, let's start off with the questions. Those others definitely they will start joining slowly. All right, so I believe that you already have the copy which was provided to you by the Nagaland Board of School Education. You are supposed to have it because your exams are approaching. So it doesn't mean that all these questions are important, but this is like it'll give you an idea on what are the type of questions that you can possibly have during the examinations. Not that only these questions will be set. No, it's nothing like that. Anyway, a very good morning to each and every one of you. Okay, all right then. So let's just continue. Let's just begin. So here, of course, especially since we are solving this question bank, I will be assuming that you already have the concepts with you. You already know whenever necessary, wherever necessary. Definitely, I'll be explaining things to you. But here, of course, unlike the other classes and all, we will not. I cannot be explaining in detail exactly all the minute details and all. So I hope I will be expecting that you have already the concepts that is required for solving each question. Wherever needed and necessary, definitely I will also be providing. Anyway, so the first question is, consider the function from defined on real numbers given by 4x plus 3. You're supposed to show that the function f is invertible and hence find its inverse. So as we know that for a function to be invertible, it has to be 1 to 1 and onto. So first we'll have to prove that it is 1 to 1 and then onto. And then once we're able to prove that it is 1 to 1 and onto, definitely it will be invertible, and then we can proceed to find out its inverse. 1 to 1 means every element will have a unique image, and onto means every image should have a pre-image, so no element should be left out. So let's just go for the proof solution. So I'll just go for the proof here. So we have, let's say that f of x, the value of the function at 2 points, at 2 different points. So what we see is 4x plus 1 equal to 3, 4x2 plus 3. So 3 we have. So we have 4x1, 4x2, 4. So that does imply that x1 is equal to x2. So which clearly implies that f is 1 to 1. So that's the first part. So f is 1 to 1. So definitely we don't have a big problem there. So that means x1, the value of the function at 2 different points will be equal only when we're talking of the same points, x1 equal to x2. So that proves that the function is 1 to 1. So now for proving onto, there are many ways to prove. This is not the only way that you can prove. There are many other ways. So every teacher, every book will have its own way of describing. So that, of course, you can choose which one is best for you. So now let's go for proving that it is onto, and once we are able to prove that it is onto, definitely it will be invertible. So now for onto, what we will do is let this function be represented by y. So it should be reversible, no? Onto image, pre-image, pre-image, image. So no element should be left out. I hope you already know the concept. So y minus 3 divided by 4 is equal to x. So y minus 3 divided by 4 is equal to x. So I'll just rub this. I believe this is done. So now if y belongs to R, which is actually the codomain of the function, codomain of the function f, codomain. I've already done videos on this, so you can go and check them out. Codomain of function, then there exists, this is for proving that it is onto, no? Then there exists x equal to y minus 3 by 4. Then there exists x equal to y minus 3 by 4, which belongs to the codomain R, such that f of x, that is supposed to be f of y minus 3 by 4 is equal to y. So we will solve this and see. So f of x, what was our function? 4x plus 3. So for this value, let's find out. So that's going to be 4x plus 3. So 4. So we have y minus 3 plus 3. 3 cancels. So what do we have? We have the value y. So definitely that proves that therefore f is onto. So since f, our function, is 1-to-1 onto, the function is clearly invertible. So the function is clearly invertible. Alright, so that's the first part is done. That is, the function is invertible, so that part is already proved. So let's go on to proceed. Let's proceed to find out its inverse. So that's not going to be a big deal. It's almost the same process. So now let's find out its inverse. So now, for inverse, we should have y equal to f of x. That's why it should be 1-to-1 and onto. No, that's the condition for it. So y equal to 4x plus 3. So as equal to x equal to y minus 3 divided by 4. So that's our inverse, because we have already proved that it is onto. So that somehow gives us the inverse also. That means, which implies, in other words, f inverse. The inverse of the function f inverse of y is y minus 3 divided by 4. So that can be as the function, since if f of x is equal to y for invertible functions, then this also implies that x is equal to what? F inverse of y. That is for invertible functions. So as I said, the basics, I believe most of us, we already know. So definitely, thus, the conclusion, the invertible function, thus, the inverse of the function, such that it is defined on real numbers r to r, such that f inverse of y is equal to y minus 3 by 4. Y minus 3 by 4. Of course, for all values of r. For all values of, let's say, y belonging to r. For all values of y belonging to the set of real numbers. So that's the first question that we have done today. So let's move on to the second question. You can get yourself ready with the second question. So that is about inverse trigonometric functions. inverse trigonometric functions. So the question is, I believe you already have the question, but anyway, short questions, small questions I'll also write down. So the question is, if tan inverse of x minus 1 by x minus 2 plus tan inverse of x plus 1 by x plus 2 is equal to pi by 4, then the question is, find the value of x. Question is, find the value of x. Of course, for us, we know that tan inverse of x plus tan inverse of y, that is nothing but tan inverse of x plus y divided by 1 minus xy. We are going to be using this value. Of course, provided the product of x and y is less than 1. So let's just use this particular theorem given to us. So that will imply tan inverse, if we just consider this as x and this as y, so that will be tan inverse of x plus y 1 minus x into y, that's equal to pi by 4. Let's do a little bit of solution on simplification here. So by multiplying by tan function on both the sides, tan inverse, that will be 1. So you will have only this value. So I'll do it directly here, taking the common LCM. So that's going to be x minus 1, x plus 2 plus x plus 1, x minus 2. I'm going to do it directly here because common LCM, here also common LCM, that is done. So x plus 12, so I believe that can be easily understood. I guess that's fine. I'm just taking the common, the LCM here, so definitely it's x minus 1 into x plus 2, x plus 1 into x minus 2. So the LCM down here is x minus 2 into x plus 2. Similarly here, the LCM will be x minus 2, x plus 2. So the common LCM, denominator is done. After that, so here what we have is x minus 2 into x plus 2. So that's x square minus 2 square. A plus b into a minus b is a square minus b square. Similarly, a plus b into a minus b, again here also, of course, minus of a square minus b square. Alright, so I am sure that that is not a big problem. So let's going back to the solution, and of course pre-multiplying by tan function on both the sides. So that's why tan inverse done 1, and then tan pi by 4. So if we just do a little bit of simplification here, let's begin. That is x square, plus 2x minus 2 plus, let's do it quickly, x square minus 2x plus x minus 2. Okay, I'll just do it here. 1 divided by x square minus 4 minus x square plus 1. Tan pi by 4, of course, that is 1. So in that case, x square minus x square, let's do a little bit of 2x minus 2x, anything else, plus x minus x. So what are we left with here? We're left with 2x square minus 4 is equal to 1. 4 minus 4 plus 1, that's minus 3. So 2x square equal to minus 3 plus 4, of course, that is 1. So that's 2x square is equal to 1. So x square equal to 1 by 2. So that would imply x equal to root over of plus or minus 1 by 2. Or in other words, x equal to plus or minus 1 by root over of 2. So that is your solution. Alright, now question number 3 and 4, that's slightly that's outside of the reduced syllabus that is given to us, so that we'll have to just confirm and check once again, because as per the reduced syllabus we say that the properties of determinants have been deleted, so I may be confused, but I don't think that these questions can be used, because properties of determinants, these are the only solutions, so I mean these are the only questions. So if I'm not mistaken, in the reduced syllabus it is given there properties of the determinants are deleted for this year. So of course, just to be safe you can prepare, but I'll be always on the safe side. So but we'll be skipping these two questions. Question number 5 also, 3 and 4 both are from properties of determinants, so we are going to be skipping that for now. If it is, definitely I'll confirm, and then if it is within the syllabus, then definitely of course I'll be uploading it for you, don't worry about that. Question number 5, of course, number A, that is again well outside the reduced syllabus, because that is about derivatives using logarithm. So for this year and that is within the reduced syllabus, so that will not be used hopefully. So we'll be going to number B, that is y is given as tan inverse of x whole square. So we have to show that x square plus 1 whole square y2 plus 2x x square plus 1 y1 is equal to 2. So using this information we have to get this statement. So that's quite simple, it's not a big thing. So alright, let's begin. So differentiating both sides with respect to x, so derivative of y with respect to x. So chain rule, this is a second order derivative, so 2 tan inverse of x into, okay, I'll just do step derivative of tan inverse of x. So that will be first order derivative, so that's usually also written as y1 twice of tan inverse of x into 1 by 1 plus x square. Now looking at the proof, 1 plus x square, so looking at the proof, you always have to keep a track of the proof also, okay, so that will give you an idea. So what I'll do is I'll just bring this up here. So that's 1 plus x square into y1 is equal to twice of tan inverse of x. So since this is a second order derivative, because it's y2, so we will again continue with our differentiation. So again continuing with our differentiation, so here we will be now following product rule, so that's going to be 1 plus x square derivative of y1 with respect to x plus y1 into derivative of 1 plus x square is equal to derivative of twice of tan inverse of x. So that is going to be 1 plus x square derivative of y, so that's going to be y2 second order derivative, plus y1 into, that's going to be 0 2x equal to 2 1 by 1 plus x square. So again multiplying 1 plus x square on the left hand side, I'll have here 1 plus x square whole square y2 plus twice x 1 plus x square y1 is equal to 2. So that's quite a very easy question for the 4 mark. So of course questions are going to be easy, so you just have to keep your cool and solve. That's going to be the key factor, especially this 2 marks 4 mark questions, no? Alright, so if we have done, we'll move to question number 6. Question number 6 here, what happens is, the first question again, verify mean value theorem. That's again out of the syllabus, reduced syllabus especially for this year. So number A we are going to be skipping. We will go to number B, that's implicit functions. So the value of x, a sine inverse t, the value of y, a cos inverse t. You're supposed to show that the derivative of y with respect to x is minus of y by x. There are many ways in which you can solve this particular question also. So what I'll do is, here I'll square both sides, that is a sine inverse t. And this also I'll square, y square equal to a cos inverse t. That might just help my cos. So I'll start with the first one. So this one I'll differentiate with respect to t now. So that's 2x dx by dt. That's equal to derivative of a power x, that is a power x log a. Then continuing with the chain rule, derivative of sine inverse of t. Let me just complete for x first. So that's going to be 2x dx by dt equal to a sine inverse t log a to the base e. Derivative of sine inverse t will be 1 by root over of 1 minus t square. So I need dy by dx, derivative of y with respect to x. Yeah, definitely you can, if you're getting the solution and then if you're not doing anything mathematically wrong, definitely you can multiply. As I say, there are different ways to solve. So this is just one way. There are other ways also. You can just try that also. No, it's not going to be until unless of course you are not breaking the basic laws and principles of mathematics. Everything is correct. So don't be worried about that. All right. So now I'll proceed with y square. So y square equal to a cos inverse t. So this one also differentiating both sides with respect to t. That's again going to be a cos inverse t log a derivative of cos inverse t. So that's going to be 2y dy by dt is equal to a cos inverse t log a. Derivative of cos inverse t is minus root over 1 minus t square. So now I'll just divide equation 1 by 2. That means I'll be marking this as my equation 1 and this maybe as my equation 2. So if I just divide both the equations, then it's 2x dx by, no, we need dy by dx. So we'll just divide 2 by 1. So dividing equation 2 by 1. So that would be 2y. That's quite simple, of course, not a big thing. 2x dx by dt. So these are very simple questions, okay, actually with respect to formulas, no. Even though the question might look very different, still there. That's a cos inverse t log a minus 1 minus t square, a sine inverse t log a 1 by root over 1 minus t square. 2, so y by x, dy by dt, dy by dx, dt. So this is also done. So we have minus of a cos inverse t, a sin inverse t. So now a cos inverse t, as we have seen, I converted that as y square. This was x square. So therefore dy by dx is minus of y square by x square into cross multiplying x by y. So then we have the proof minus of y by x. So this is also a simple way to solve and get the proof. Alright, move on to now question number 7. This will be from application of derivatives. Application of derivatives, the first question you can, just get that ready with. Rate of change. Alright, I'll not write down this question, it's quite lengthy, so I believe you already, as I said, you have the copy with you. Question number 7, A. The length x of a rectangle is decreasing at the rate of 5 centimeters per minute, and the width, that is the breadth, y is increasing at the rate of 4 centimeters per minute. Alright. When x is equal to 8 centimeter and y equal to 6 centimeter, find the rate of changes of the perimeter and of course the area of the rectangle. So that's a very simple question since it is given. Okay, just it's given that the length is mentioned as x and width is mentioned as y. Now rate of change, that is rate of decrease for length, that is dx by dt rate, that's given as 5 centimeters per minute, decreasing. So that's when you minus 5 centimeters per minute. Similarly for width, rate of change, what? It is decreasing or increasing. This time rate of change width is increasing by 4 centimeters per minute. So that's very simple there. Alright, that's given to us. Now if you go for the first question, the first part, that is, if when x equal to 8 and y equal to 6, find the rate of changes of the perimeter. So, okay, if we just assume, I'll just write, let P be the perimeter. So what will be the value for P? That is twice of length plus twice of breadth for a rectangle. Remember, we are dealing with a rectangle here. So now I'll differentiate both sides. Since these are the informations that I have, I'll do it directly simple. Rate of change, I'll differentiate that with respect to t. So twice of dx dt plus twice of dy dt. That will give you the rate of change. So that will be simply twice of, I'm just taking common, dx is minus 5 plus dy by dt is 4 centimeters per minute. So that's going to be minus. So minus 2 centimeters per minute. So with the perimeter, what happens is, since it is negative value, we can write that the perimeter is decreasing, D-E-C-R-E-A-S-I-N-G, decreasing at the rate of minus 2 centimeters per second. At the decreasing, so since everything decreasing, that's enough, decreasing at the rate of 2 centimeters per minute. So this is, of course, a very simple question, rate of change. Alright, similarly, let's go for the area. So if we go for the area, then okay, this is the second one. So of course let A be the area. So in that case, area of course length into breadth. So rate of change differentiating with respect to t, x dy by dt plus y dx by dt. Now the value of x and y is also given to us. That is x is 8 when x is 8. Rate of change of y, how much was that? 4. Plus y is 6. Rate of change for the length was minus 5. So on this 32, 230, so 2 centimeters per minute. So that value that here is 2 centimeters square, sorry, centimeter square area. So centimeters square per minute. Because x is centimeter, this is also centimeters, of course centimeters square per minute. So here what happens with the area? Area is increasing, I guess you can write that, increasing at the rate of 2 centimeters squares per minute. So perimeter was decreasing, area here of course is increasing. So a very simple question there. Okay? Alright. You know the basics? Question is easy. You don't know the basics? Question is absolutely difficult for you. So it's all about practice. Mathematics, definitely it's all about practice only. You can never be overconfident with mathematics. Alright, number B. Find the points. Again, this is from application of derivatives, tangents and normals. So find the points on the curve. Find the points on the curve x square. So this is the given curve is x square by 9 plus y square by 16 is equal to 1. So find the points on this curve. Let this be question 1. So you're supposed to find the points on this curve. Definitely this is an ellipse. This is going to be a vertical ellipse, if you remember. Yeah, this will be representing a vertical ellipse. I'm just showing. So you are supposed to find out the points on the curve at which the tangents are parallel to the x-axis. The tangents where it's parallel to the x-axis, at which point is it going to be parallel to the x-axis and parallel to the y-axis. So we'll have to solve and we'll have to get those points where the tangents on this curve would be parallel to the x-axis and would be parallel to the y-axis. So definitely after we get the solution, we will discuss about the solution also, but still then let's just go straight to the point and first solve. So what I'll do is I'll just differentiate this equation first with respect to x. So that's 2x by 9 plus 2y by 16 dy by dx equal to 0. We need to get the slope. So 2y, that's going to be y by 8 dy by dx is equal to minus 2x by 9. Or the slope dy by dx is equal to minus 16x divided by 9y. So concepts on derivatives are already given to you. Okay, please go back and watch those videos again and again and again. There in one video I've already described to you that dy by dx also denotes the slope. So alright, let this be the equation 2. So that's what we have with our given curves. Now for the first case, that's the first condition. I guess this is done. Alright, number A, I mean. Find the points on this curve where the tangents are going to be parallel to the x-axis. That's the first question, parallel to the x-axis. So you have to write down for a tangent to be parallel to x-axis, kindly note down. I'll just have a sip of water. Alright, so for a tangent to be parallel to the what? X-axis, what should we have? For a tangent to be parallel to the x-axis, we should have dx by dy equal to 0. For a tangent to be parallel to the x-axis. For a tangent to be parallel to the x-axis. This is a question, if you wish to know, from exercise 6.3, question number 20. Question number 13. Okay, exercise 6.3, question number 13. If you wish to know from where this question has been set, you can just check out exercise 6.3, question number 13. So when you practice, you can just get the solution done from there. So you can just try and solve. So for a equation to be parallel to the x-axis, we should have dy by dx equal to 0. Dy by dx equal to 0. So I hope you have solved dy by dx equal to 0. So quickly, that's minus 16x divided by 9y equal to 0. So of course that implies x equal to 0. It's as simple as that. Therefore x equal to 0. It's not a big deal with that. X equal to 0. So you put x equal to 0 in equation 1. You get the point. So putting x equal to 0 in equation 1. So what do we have there? X equal to 0, that is 0. So y square by, what was our equation there? Y square by 16. Y square by 16 is equal to 1. Y square by 16 is equal to 1. So in that case, we have y square equal to 16. So y will be equal to plus or minus 4. Y equal to plus or minus 4. So the points on the curve for the tangent to be parallel would be, therefore the points are 0, 4 and 0, minus 4. So that's why if you see, that's why I gave you the diagram also. Since we're talking of an ellipse, for any tangent to be parallel to the x-axis, what should happen here is, it can happen only in these two cases. Then only in these two cases we can have the tangent through the curve parallel to the x-axis, because we're talking of a perfectly symmetric vertical ellipse here. So automatically, exactly, we get the points on the y-axis only. Alright? Okay, let's move on to the second part, that is for a tangent to be parallel to the y-axis this time. That means most probably we'll be having parallel lines like this. And in that case, what we should have is dx by dy should be equal to 0. So let's quickly solve that. Dx by dy equal to 0. So what was our value of dy by dx? Dy by dx was minus 16x by 9y. So that's going to be minus 9y by 16x equal to 0. So that would imply y equal to 0. So quickly putting y equal to 0 in equation 1 we have x square by 9 equal to 1, so that's x equal to plus or minus 3. So again, therefore the points are 3, 0 or minus 3, 0. So that's why the points here now will be lying on the x-axis. So as it is, exactly so. Alright, okay. I guess that's done. Not a very difficult question at all again. So just remember these equations. For a tangent to be parallel to the y-axis, dx by dy equal to 0. For a tangent to be parallel to the x-axis, dy by dx equal to 0. It's about that line, no? X equal to 0, y equal to 0. The equations, respectively, their slopes also. The next question. Next question, please. Question number 8. Number 8. That's again from application of derivatives, rate of change. Sand is pouring from a pipe at a rate of 12 centimeters cube per second. That's about volume. The falling sand forms a cone on the ground. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. So the falling sand is forming a cone in such a way that the height of the cone is always 1/6 of the radius of the base of the cone. How fast is the height of the sand cone increasing when the height is 4 centimeter? Rate of change of height when the height is 4 centimeter. Alright, so let's just write down let at any instant t. Let at any instant, let's just say at any instant t, at any time t, let r be the radius and h be the height of the cone, and h be the height of the cone. In that case, what will be the volume of cone? The volume of cone, what will be the volume of cone? Volume of cone, this condition remember we already have, okay? So volume of cone is 1 by 3 pi r square h. So that's the volume of cone. So let's just use this information and try to solve. So volume of cone, that's, let's say, denoted by V, 1 by 3 pi. Let's use the substitution, that is, what can we use? So that would imply what? R equal to 6 times of h. We can mark this as our equation, let's say 1. We can use that information. So that's going to be 6h the whole square into h. So the volume equation 1 by 3 pi 36h cube, or in other words, V equal to 12 pi h cube. So that's the equation of the volume for us, volume of sand falling down and forming a cone. So now rate of change of volume is given to us, so we'll take that information also. So now, since it's rate of change, what will happen is dV by dt. We will use this equation, dV by dt equal to, since its variable here is h, rate of change of height, what we can do is dV by dh into dh by dt. That way we can form our equation with respect to the given conditions. So now rate of change of volume that is given to us is 12 centimeters cube per second. dV by dh, if we differentiate this, dV by dh, that will be 12 pi 3h square into, we are supposed to find out the rate of change of height, so that we are not supposed to know, dh by dt, and that is what we are supposed to solve and find out. So if we just cross multiply centimeter cube, forget about that, so that's going to be what, 12 12 pi into 3h squared dh by dt. So that means dh by dt rate of change is given by the equation 3 pi h squared. So now the question was, find the rate of change of height when the height is 4 centimeters. So let's find out. So the rate of change of height when the height is at 4 centimeter, 1 by 3 pi 4 square. So that's going to be like 16. 4 square is 16. 16 3 is 48. So 1 by 48 pi rate of change of height centimeters per second. Bas, that's it. Simple as that. Moving on to the second question, number B. I guess you're done. Alright, let's move on to the second question, that is again from tangents and slopes only. Again from tangents and slopes. Find the equation, almost same. Find the equation of the tangent to the tangent line to the curve dy by dx. So given curve is dy y equal to x square minus 2x plus 7. Let's find out the slope of this curve. Let's find out the slope of this curve. That is dy by dx is equal to 2x minus 2. Done. Now this time what are we supposed to do is the first one. That is, find the equation of the tangent line to the curve which is parallel to another given line. So remember, parallel lines will share the same slope. Parallel lines will share the same slope. So number one, the equation of the line that is given to us is 0. So we just convert 2x plus 9 equal to y, or y equal to 2x plus 9. If you remember the equation of a line in slope intercept form, y equal to mx plus c. So where the slope is given by m. So in that case, what is the slope of this line? In that case, the slope of this line is, since it is in the form of y equal to mx plus c, that will be 2. So the slope of this given line for the first question is 2. Done? So in that case, what will happen? Find the equation of the tangent line to the curve which is parallel to our given line. So in that case, as I said, they will share the same slope, isn't it? Because if you remember, if two lines are parallel, then their respective slopes are equal. If two lines are perpendicular, these are all learned in class 11, then the product of their slopes is -1. We're going to be using that concept only. So in that case, we will write down the equation, that is, if a tangent line is parallel, to the given line, then slope of the tangent is equal to slope of the line. I guess this information is already written. I'm rubbing this off now. So in that case, what was the slope of our tangent? Dy by dx. The slope of our line, how much was that? M, whatever be it. So in that case, our solution is dy by dx is what? 2x minus 2. The slope was 2. So that's like 2x equal to 2 plus 2. So 2x equal to 4. Or in other words, if you wish, x equal to 2. X minus 2 equal to 0 if you need an equation. No problem with that. Alright. Okay, I'll just rub this off because this equation we already have, so we'll go to the second condition where it is about perpendicular now. So for the second case, we're supposed to find for perpendicular to the line. So the given line is y, where is it? Okay. 5y minus 15x is equal to 13. So I can convert 5y equal to 15x plus 13. So y equal to 15 by 5x plus 13 by 5. So y equal to 3x plus 13 by 5. So here the slope is 3. Y equal to mx plus c. So definitely here the slope is 3. Sorry. We did not get the equation of the line also. Again, this one will be done. This is half done only. Sorry, x equal to 2. We got. Sorry, I got I skipped. That skipped off my mind. So x equal to 2. That is what we get. All right. So once you get x equal to 2, you put when x equal to 2, then equation 1. What was our equation 1 that we use? Y equal to the first equation, y equal to the equation of our tangent was x squared minus 2x plus 7. So that's going to be 2 square 4 minus 2 to the 4 plus 7. So in that case, the value of y will be 7. In that case, y equal to 7. Y equal to 7. We still have to get the equation of the tangent. Nah? This one I was just quite getting the point. Alright, so once this is done, write down the point on the given curve. The point on the given curve at which the tangent is parallel to the given line is 2, 7. So equation of tangent, if you remember, y minus y1 equal to m into x minus x1. This was the equation of tangent, or not only equation of tangent, equation of a line passing through a point having slope m. So we're supposed to find out the equation of the tangent, which is parallel to another line passing through a point. So it gives us the same condition. So that's y minus y1 is 7 equal to slope was 2, x minus 2. So y minus 2 equal to 2x minus 4. In other words, 0 equal to 2x minus y minus 4 plus 2. So we'll have 2x minus y minus 2 equal to 0. So that's the equation of the tangent for us. Y minus 7, not 2, y minus 7, so minus 4 plus 7, so that's going to be, of course, 3. So 2x minus y plus 3 equal to 0. So that's the equation. So that's just the first part of the question done. Let's move on quickly then to the second part of the equation. So second part I've already done half, but anyway I'll do again. So second part was about perpendicular. So the line is, I'll have to do it again. So that the what was the line? 5 y minus 15x is equal to 13. So y equal to 15x plus 13 divided by 5. In that case, y equal to 3x plus 13 by 5. So here the slope is 3. So the slope of the line tangent, which is perpendicular, is 3. So what will be the slope of our required line? So since the tangent line is perpendicular to the given line, what will be our, let's say if our slope is m1, then m1 into m, let's say this is m1, should be -1. So in that case, our slope will be, the slope of our tangent will be -1/3. So in that case, that implies dy by dx is equal to what? -1/3, slope of our required slope of the tangent of our line. So what was our equation? Dy by dx, 2x minus 2. So 2x minus 2 is equal to -1/3. So 3 2s are 6x minus 6 equal to -1. 6x equal to -1 plus 6. X equal to 5/6. X equal to 5/6. So now let's get the point again. In equation 1, get the point. So putting x equal to 5/6 in equation 1. So what was our value of, again, y was, where has it disappeared again? X square, 5/6 square minus 2x, 5/6, come on here, plus 7. I hope you're not getting tired, bored. Of course, as I said, you had to come prepared. So this one I'll give you the value directly. I calculated it. So this will be 217 by 36. You can save some time because of that. 217 by 36. So simple. So the point on the given curve we can write down. So the point on the given curve where the tangent is perpendicular to the line is what? 5/6, 217 by 36. So what will be our equation then? In that case, equation of tangent line will be y minus y1, 217 by 36 is equal to m. What was our slope? -1/3. X minus x1, 5/6. So like 36y minus 217 by 36 is equal to -1/3. 6x minus 5 divided by 6. 6 at 36, 3132. So I believe if you simplify, what shall we have? Well, anyway, 36y minus 217 is equal to -2. 6x minus 5. So 36y minus 217 equal to -12x plus 10. So 12x plus 36y minus 217 minus 10 equal to 0. 12x plus 36y minus 227 equal to 0. Minus 12x plus 0 equal to 0. Whew. Hello everyone, how are you? I guess you're all doing fine, no? This is just question number 8. we still have a long way to go. We'll try to solve as much as possible today. Of course, if it goes beyond, then definitely we'll stretch it to another session. But let's just try. I guess you are all up for maybe another half an hour, can we? Do you want half an hour or you want another full hour session? It seems like only there are two people who are still alive there who haven't still slept. Come on, give me some response. Sumonti, you have responded. Jati, you have responded. What about the rest? They've all gone back or what? Give me some response so that I'll also know, because next up it's about integration. So, okay, Arun wants to go for 1 hour. Pinky, okay, Pinky is also there. Let me know who else is there again. And please inform your friends also to come and join, because of course they can watch the later on also. But learning together is much more fun. Sumonti is there, Jati is there, Arun is there, Pinky is there, Im Jong is there, Chong is there. Okay, who else is there again? Come on, give me a hi or something like that. Youngaman is there, Mong is there. Alright, good to see so many of you coming back. It's been a long time. Pusinup is there, good morning. Alright, without wasting much time, let's complete all the 4-mark question in this session. We will try, Rahul, but Bapri, I'm also exhausted actually. It's been almost how many hours? Like it's almost been 1 hour. So we'll try our level best, because after this again I have to rush back to my duty again. I have to rush back to the school again. After this immediately I have to go back again. It's 10, so let's try as much as possible. We'll try to finish again. Alright, finish. Let's go back to now the integration part. So this comes from the partial fraction integration part. 2x divided by 2x divided by x squared plus 1 into x squared plus 3. Alright, let's move on. And then of course, yeah, if you still haven't liked the video, at least give me a like. If you still haven't subscribed, at least subscribe. I guess you have done that. Anyway, forget about that, just kidding. Alright, let's continue. So this is from partial fraction exercise. So let x square equal to t. That would imply differentiating both sides. 2x with respect to x would be dt. In that case, my I would be dt divided by t plus 1. So in that case, it becomes a simple case of partial fraction. T plus 1 into t plus 3. Alright, so if you remember, then I've done a video on this also. Then let 1 by t plus 1, t plus 3, t plus 3, isn't it? T plus 3, yes. 2x dx, fine. So these are non-repeating terms, so a into t plus 1 b by t plus 3. So this should be our equation 1. In that case, 1 will be equal to a into t plus 3 plus b into t plus 1. Alright, welcome back. There was a small problem with the network there. So I've solved the values of a and b for you. So I guess that is done. So let's go back to the question again. Sorry, there was a small network error. Of course, I couldn't do anything about that. So, alright, so the value of a and b are already done for you. Fine, then it was a welcome break, I guess, for all of us. So in that case, then our equation 1 becomes t plus 1, t plus 3 is equal to a value 1 by 2, t plus 1 plus b value minus 1 by 2, t plus 3. So in that case, our integral I simply is 1 by 2 integral of 1 t plus 1 dt minus 1 by 2 integral of 1 by t plus 3 with respect to t. Then that's of course 1 by 2 log of t plus 1 minus 1 by 2 log of t plus 3 plus of course the integration constant if you wish. So that's going to be log of t plus 1 divided by t plus 3 plus c. So if you wish, that's log 1 by 2 log of t value we have used as x squared. So x squared plus 1, x squared plus 3 plus c. So that can be your value then. Alright, okay, so that's the first part. Now let's go to number B, question number 9, B. Question number 9b. That's from integration by parts. So the question is evaluate sine inverse of integral of sine inverse of 2x by 1 plus x squared. Alright, so this is of course not a very difficult question, a simple question only. So with respect to x, so we'll do some substitution here. So let x be tan theta, so that would imply of course theta equal to tan inverse x. So in that case, not x, let's use 1 plus x squared. Let 1 plus x squared equal to t. I guess that will be better. What can we do is let x equal to tan theta. So in that case, my integration I will be sine inverse of twice tan theta by 1 plus tan square theta with respect to x. So that would imply this one. In that case, theta will be tan inverse of x. Alright, so that will be sine inverse. This is sine of 2 theta with respect to theta. Give me a moment. I think I'm slightly confused here. Just that going back offline again, no? Just alright. Let's begin. So sorry, since we went offline, my concentration focus just went off. So let 1 plus x squared equal to t. So then that gets 2x with respect to x equal to t. What we were doing is correct only. Sorry. So x equal to tan theta. That means theta equal to tan inverse x. So dx equal to theta equal to 1 by 1 plus x squared. Alright, fine. Welcome back. Network is really giving me some problem today. Alright, anyway. So I'll just continue. Focus. Even I lost my focus there because of this network problem. So now 2 tan theta by 1 plus tan square theta. What we did in the beginning was correct. I don't know what happened. Anyway, please forgive me for that. I'm also human. Sometimes it happens, as I say. Sine 2 theta equal to dx, whatever be it. So that would be, in that case, integral I would be twice of theta dx. So that will be twice of theta is tan inverse x with respect to x. So that's what we are going to be integrating now. So I guess this is done. So that's 9, number continuation of number b. So my I was the integration of twice of tan inverse of x with respect to x. So we would be now using here integration by parts formula. So what I'll do here is twice of tan inverse x. So tan inverse x, I can write it as tan inverse x into 1 with respect to x. So if you still remember, then ILATE, the inverse trigonometric functions, the integration by parts formula, we always prefer the inverse first: logarithmic, algebraic, trigonometric, and exponential. So that's my tan inverse x. We do not have the value of the integration directly, so that's why I'll have to use it as integration by parts. So after that, we can just continue. That is I first. So what was the integration of by parts? If you remember, integration by parts, u into v with respect to x was, what was it? U integration of v minus whole integration of derivative of u integration of v with respect to x, its whole integration. So let's do that. So that is going to be, first function is tan inverse x. Tan inverse x of 1 with respect to x minus integration of derivative of the first function, tan inverse x into derivative of the second function, its whole integral. Alright, so that's going to be twice of tan inverse x into x, because integration of 1 with respect to x is x, into derivative of tan inverse x is 1 by 1 plus x squared into x with respect to x. So this multiplies, so 2x tan inverse x minus 2x 1 plus x squared with respect to x. So that's going to be 2x tan inverse of x minus this 2, I'll take it inside, 1 plus x squared with respect to x. So that can be simply written as now I equal to 2x tan inverse of x minus log of 1 plus x squared plus c. Finally, sometimes what happens is, even for us, we are humans, concentration just blows off. Of course, it's been now almost more than 1 hour, so concentration focus just blows off, and that time, like, honestly speaking, we also do not know what is going on. So it's not only you, it's even with us also. So that's why this problem, I don't know for what reason, such a simple problem, I do not know for what reason was giving me some problems. Not problems, it's actually the problem was because of the focus and the concentration, and then again network was going on and off. That problem was also there. So please, I'm sorry for that. Alright. I guess that's done. A simple question finished. Let's move on to the next question, if we can, quickly. That would be now question number 10. Question number 10a, that is evaluate x plus 3 divided by x squared minus 2x minus 5. This is from the special integrals again. This is from the special integrals, special integral part. So if you remember again that one, this also I've already done videos on it properly. So x plus 3, let x plus 3 x squared minus 2x minus 5 is equal to, let the denominator, let x plus 3 equal to what? A into derivative of x squared minus 2x minus 5 plus b. Question 1. We're going to partial break this so that we can integrate it. So that's going to be x plus 3 equal to a into 2x minus 2 plus b. Let's try to solve this. X plus 3 equal to twice of ax minus 2a plus b. So by comparing the coefficients, I'm not going to write that here. Comparing the coefficients, we get 2a equal to 1 and minus 2a plus b is equal to 3. So from here, of course, we have a as 1 by 2. So that if we just use it, substitute here, we'll get the value of b. So that will give me minus 1 plus b equal to 3. So b equal to 3 plus 1, that is going to be equal to 4. So that job is done. So a is 1 by 2, b is 4. So now going back to equation 1, so therefore from 1, x plus 3 can be written as, this will be our equation 1, not this one. So this is just the first step. So from equation 1, x plus 3 actually can be written as a, what is it? 1 by 2, 2x minus 2 plus b value 4. So now we can go for the integration. So therefore I would be 1 by 2 2x minus 2 plus 4 upon x squared minus 2x minus 5 with respect to x. Our job would be now to integrate this. In that case, I can write as 1 by 2 by splitting them, 2x minus 2 divided by x square minus 2x minus 5 with respect to x plus 4 into integral of 1 by x square minus 2x minus 5 with respect to x. So that, if we wish to do it separately, we can write 1 by 2I1 plus 4 times of I2. So if you remember, I have a habit of getting this equations confused. So I'll just write here I equal to 1 by 2I1. This is for me only, okay? Because once I rub it off on the board, it becomes very difficult for me to find out where the equation is. Alright, I guess that's done. So now let's integrate them one by one. So the first one, integration should not be a problem. So I1 would be simply integral of 2x minus 2 x square minus 2x minus 5. So as I had told you earlier, no, this is a direct application only. That's why this process was given to us. So if you, what is the derivative of x square minus 2x minus 5? 2x minus 2. So that's immediately log of x square minus 2x minus 5 plus c1. And I2, let's integrate that, will be 1 by x square minus 2x minus 5 with respect to x. Let's complete the square. So that will be integral of 1 by, completing the square method, x square minus 2x into 1 plus 1 square minus 5 minus 1 square with respect to x. So that would give us 1 by x minus 1 whole square minus 5 minus 5, 6 with respect to x. So that would be integral of 1 by x minus 1 whole square minus root over of 6 whole square with respect to x. That is my I2. Now we'll be needing the formula for the special integral. So if you remember, what was the formula for the special integral for this? You can just check out your book also, no problem. You can just check out your book and then have a look. So that was 1 by twice of a log of, if you remember, integration of 1 by x square. We don't have a coefficient here for x. It's free, as I said. That's why with substitution also you can do, without substitution also, because it's not going to change the value. That is, x is x. Minus 1, don't worry about that. So you can just consider this as x only. So x square minus a square. Formula was 1 by 2a, if you remember, log of x minus a divided by x plus a plus c2, if I'm not mistaken. Alright, so I guess that's done. 1 by 2 root of 6 log of x minus 1 minus 6 x minus 1 plus root of 6. Alright, now time to go back to our main equation. So this is I1, I2 all done. So then finally, therefore, what was our I equation? That was, okay, 1 by 2 I1 plus 4 times of I2. So that's 1 by 2 I1 log of x square minus 2x minus 5 plus, okay, this time I'm not going to forget, 1 by 2 C1. Remember last video I had forgotten about this previously when I used to do this. 4 times of 1 by 2 root of 6 log of x minus 1 root 6. When you do it for a very long time, what happens, human brain, we cannot focus for so long. That's one problem. 4 times of C2. So that's when you always have to take a sip of water. That will help you cool down. Alright. So that's going to be 1 by 2 log of x square minus 2x minus 5 plus 2. 2 by root 6 log of x minus 1 minus root 6 x minus 1 plus root 6 plus c. where the value of c is nothing but 1 by 2 c1 plus 4 of c2 is constant, so it should not give us any problem. So 1 by 2 log of x square minus 2x minus 5 plus 2 by root 6 log of x minus 1 minus root 6 x minus 1 plus root 6 plus c, the integration constant. I believe all of you are still there. Alright, now the next question of course will not be a part of the syllabus because that will be from outside of the syllabus, from the reduced syllabus, because that is limit as a sum, so that is being reduced for this year. So now we'll move on to number 11, that is integration using properties. Integration using properties of integrals. So these are very simple question, okay, integration using properties of integrals. 0 to a root of x divided by root x plus root of a minus x with respect to x. For this you will just need one property, that is the property 0 to a f of x with respect to x can also be written as f of a minus x with respect to x, 0 to a. You are going to need this property. So I'll just mark this as equation 1. Then I'll start using this property 0 to a. Since we know that this property holds, I'll use f of a minus x. What is a here? This function is root x, so that also now, that means whatever is the function, x can be written as a minus x. So x, here also limits are all same, so that doesn't confuse us much. So x can be written as a minus x divided by, here x also again a minus x plus, that means value of a will now change into a minus x, whatever be the upper interval here, a, 2, 3, 4, whatever be the upper interval. So that's going to be a minus x value now will change as a minus x with respect to x. I hope you got that point. So that's going to be 0 to a root over of a minus x divided by root over of a minus x plus a minus a done, minus minus plus, so you will have root over of x. This I'll mark as equation 2. A very simple question. So adding equation 1 and 2. So if I add 1 and 2, I'll have I plus I, both sides, is equal to, I'll just write 0 to a. First equation was root of x plus root over of a minus x with respect to x, plus again within the same interval 0 to a root over of a minus x divided by root over of a minus x plus root over of x with respect to x. By basic operation of integration, what we can do is, if we have the integrals under the same limit, we can add them. So that means we see 0 to a with respect to x, so that means I can be added 2i equal to 0 to a. So if you just, okay, I'll just write for the first question. Root of x plus root of a minus x plus root over of a minus x, root over of a minus x plus root over of x with respect to x. You will see that we have a common LCM here. Root over of x plus root over of a minus x. So no changes. A minus x with respect to x. Actually, these are very, very simple questions. Okay, you miss out on this, then it's a big loss for you. Without doing anything, you get the marks in. So all my chalks are getting damaged. So you have the same term, so and you'll have 1 with respect to x because this 2 cancels out. So what do we have? 0 to a, 2i. So in that case, what do we have? 2i equal to integral of 1 with respect to x, that is only x, 0 to a. So that's like 2I equal to upper interval a minus lower interval 0. Done. So I guess this is done. So that's simply 2I equal to a, or in other words I equal to a by 2 bus. Alright, fine, that's set. Let's move on to the next question, that is number 12. Is it done? Alright, let's move on to question number 12. That is I equal to 0 to pi x divided by 1 plus sine x with respect to x. So here also I believe we will start off with the same property that we used. So maybe, okay, alright, let's just mark this as equation 1. So using that same property, f of x also is f of a minus x. Same property, that is 0 to a for a function is also 0 to a f of a minus x. But what is the value of a here? That only changes here. Unlike the other question, it's pi. No problem. So x will be now pi minus x. 1 plus sine of pi minus x with respect to x, 0 to pi. So I is pi minus x, 1 plus sine of pi minus x, second quadrant, so that still remains sine x only with respect to x, 0 to pi. Maybe I'll just mark this as equation 2. So let's see what we have if we add 1 and 2. So adding 1 and 2, 2I equal to 0 to pi x, 1 plus sine x with respect to x plus again 0 to pi. What do we have? Pi minus x, 1 plus sine x with respect to x. So 2I, common integral 0 to pi, common limit. So common LCM, I'm doing it directly now, 1 plus sine x with respect to x. So that's x plus pi minus x. So we have 2I is equal to 0 to pi, x we cancel. So we have pi by 1 plus sine x with respect to x. Alright, okay. So in that case 2I equal to pi 1 by 1 plus sine x, 0 to pi. Now to solve this, we have already done this type of solutions. I will multiply and divide the numerator and denominator by 1 minus sine x. In integration, these are common procedures. I equal to pi by 2, 0 to pi. This 2 also I'm bringing it down. So 1 minus sine x, 1 plus sine x into 1 minus sine x. Actually, this is 1 minus sine square x. So that's pi by 2 integral of 0 to pi 1 minus sine x. This is what? Cos square x with respect to x. I guess now you're getting the point where we are approaching. So in that case, I equal to pi by 2, 1 by cos square x minus sine x by cos square x with respect to x, 0 to pi. So that's I equal to pi by 2 integral of 1 by cos sec square x. Sin x by cos x is sin x by cos x is tan x. 1 by cos x, one more cos x will be left. 1 by cos x, that will be sec x, tan x sec x with respect to x, 0 to pi. So I equal to again pi by 2. Alright, what is the integration of sec square? That is tan x. What is the integration of tan x into sec x? That is sec x. Sec x 0 to pi. So now integration is done, just time to now use the limits. So that's I equal to pi by 2. Upper limit first. So tan of pi minus sec of pi minus tan of 0 minus sec 0. So I equal to pi by 2. Tan pi is 0 minus sec pi is minus 1 minus tan 0 is 0 minus sec 0 is 1. Cos 0 is 1, so definitely sec 0 will be 1. So that's pi by 2 minus minus plus 1 minus minus 1. So that's pi by 2 into 1 plus 1, 2. So I will be nothing but how much? Pi. Alright, so that's question number 12 done. Then we have 13, 14. Ooh, we have so many more questions. 17, 18, 19, 20. So I guess we'll have to continue this with another session. So I think we are all tired now. I guess it's been almost now 2 hours. So we'll wind up here for today if it's fine. Right, we'll wind up here for today. So we are stopping at question number 12. So that means next class we'll be starting from number 14 onwards. That's about differential equations. So we have differential equations left with us, then probability. So in the next session we'll try to do, because 6 mark also again is going to take a long time. So the next session we will try to do the remaining 4 mark questions and half part of the 6 mark question. So we'll try to wind up all this in 2 more sessions. Okay, so we'll try to wind up this in 2 more sessions. So the next session, some 4 mark questions we'll do all, and then some 6 mark questions. And in the last session, we'll try to wind up all the 6 mark questions. I guess that's fine for all of you. So, alright then. Thank you, each and every one of you. Please work hard, study well. I'll see you again in the next session. That is maybe let's see, maybe today evening if possible, or maybe tomorrow. I'll let you know. Alright, I will be updating that very soon. Alright then, see you then. Take care. Bye bye. Have a good day, all of you.